Okay, in the next few problems, we're going to apply the first derivative test to find where f of x is increasing and decreasing and find the relative max and min points. So here's our first example. F of x is equal to x cubed minus 3x squared. So we're going to start by taking the derivative. We're going to do a plus minus analysis on f prime. Let's take the derivative. We have 3x squared minus 6x. Now remember, critical points occur where f prime is equal to 0 or does not exist. Well, since we're working with polynomials here, f exists, f prime exists everywhere, and is continuous everywhere. So really, all we need to do for polynomials is find where is f prime equal to 0. So that's what we'll do. Where is it equal to 0 for critical points? So right now we're going to find critical values, CV. All right, so let's just factor out 3x. And we see that we have two critical values at x equals 0 and x equal 2. All right, so those are our critical values. We're going to put them on the number line. So for polynomials, we just put places where f prime is equal to 0 on the number line. So that here, that would be 0 and 2. And we're just going to do a plus minus analysis of f prime. Okay, let me write down what f prime is equal to underneath. F prime, I'll write it in factored form, 3x times x minus 2. All right, so it's not hard to do a plus minus analysis here. Just substitute in values and you will see that f prime is positive here, negative here, and positive here. Well, if f prime is positive here, that means the function is increasing. That is, f is increasing. F prime negative here, then f is decreasing. And on this interval, f is increasing. So from the way this looks, it looks like we have a maximum here. All right, so we have a, I'll say max. It's actually what we call a relative max, but we'll just say max. Max at 0 and f of 0. That we'll see what that is in a second. And here this looks like a min down and up. Min at 2f of 2. All right. Let's do f of 0. Okay, we're going back to this function, f of x, substitute in 0, and we see that easily that f of 0 is equal to 0. So that means that 0, 0 is a max. All right, here let's figure out f of 2. All right, substituting in 2 into this function, we have 8 minus 12, which is negative 4. Okay, so f of 2 is equal to negative 4. And we have that 2 minus 4 is a min. Furthermore, just from this plus minus analysis, we see that right here the function's increasing. We have the intervals on which the function's increasing, decreasing, negative. Between 0 and 2 is decreasing. Between 2 and infinity is increasing. So we would say between minus infinity and 0, that's increasing. Between 0 and 2, we have decreasing. And between 2 and infinity, we have increasing. So that's all in the information that the first derivative test gives us. It gives us the max min points and the intervals on which f of x is increasing and decreasing. And that's all that's required for this problem. Just to give you an idea of what's going on here, I'm just going to draw a little graph of this function. We can easily see that by factoring, if we factor out x squared, this function is 0 at x equals 0 and x equals 3. So let's just draw a quick little sketch. All right, at 0 and at 3, we have x-intercepts. And now let's put in these max min. So we have a max min at 0, 0. So in order to draw, a max at 0, 0, I'm just going to draw a little max here, up, down. And this is a min, 2 minus 4. So here's 2 minus 4 right there. That's a min, so it would go down, up. All right, just connecting all the sides, we get the graph of the function. Connecting these pieces, the function goes up, and we know it's increasing here, and then here it's decreasing, and down to this point here it's increasing, and it just continues increasing. So that's our graph. All right, here we have f of x is equal to 3x to the fifth minus 20x cubed, and we're going to do a first derivative test. F prime of x is equal to, just take the derivative, 15x to the fourth minus 60x squared. Let's factor this. Let's pull out a 15x squared. And here we have x squared minus 4. All right, continue factoring. We have 15x squared, x plus 2, x minus 2. Since f of x is a polynomial, the only critical values will be where f prime is equal to 0. So if we check where f prime is equal to 0, okay, we can see it just from that factorization. We have x equals 0, x is equal to minus 2, and x is equal to 2. So these will be the critical values. We'll put them on the number line. So we're doing a plus minus analysis of f prime. So in order, we put the minus 2, the 0, and the 2. Notice in the factorization, x squared, the 0, the factor where the critical value x equals 0 comes from is x squared. Since it's squared in this plus minus analysis, we aren't going to have the alternating positive negative pattern. All right, here we'll have f prime is positive to the right if we plug in something like 3. Here if we plug in a 1, we'll see we have positive, positive, negative, so that's a negative here. If we substitute in, let's say, minus 1 here, we're going to have positive again because of the x squared, positive, positive, negative again, so 2 negatives in a row over there. And here if we substitute in, let's say, minus 3, we'll have positive, negative, negative, so that'll be positive. So that's the plus minus analysis. That means here the function is increasing, decreasing, decreasing, increasing. Remember, positive increasing, negative decreasing. And now let's write that right here, f prime, f is increasing. Let's draw something going up, down, down again, and up. Now because of this up-down pattern, that means here we have a max, here we have neither a max nor min, and here we have a min. So that is a max at minus 2, f of minus 2, we'll figure that out in a second, and a min at 2, f of 2. Okay, so let's just do f of minus 2, we're substituting now into f of x, so we have f of minus 2 is equal to 3 minus 2 to the fifth, that's negative 32, subtract 20 times minus 8, and this comes out to 64. F of 2 is 3 times 32 minus 20 times 8, and this comes out to negative negative 64. So we have a max at minus 264 and a min at 2 comma minus 64. Okay, at this point we're not officially graphing yet. We'll be doing that later on in this chapter, but I think we can just sketch a little graph of this just so that you can see what's going on here. All right, so using this information, here's how we would sketch the graph. First, let's factor this to find the x-intercepts. Let's pull out x cubed. And from this, we get the x-intercepts. X equals 0, coming out of here, and coming out of here, we have x squared is equal to 20 over 3, so we have x is equal to plus or minus the square root of 20 over 3, which is approximately plus or minus 2.6. All right, so these just for the x-intercepts. So here's 1, 0. Let me put down 1, 2, and let's just put 2.6 over here. And 1, 2. Let's put minus 2.6 over here. All right, so there's that 2.6 and minus 2.6. And 0. Okay, so those are the intercepts. Let's put the max and the min. The max is at minus 264. Now, I'm not going to draw this to scale. Let's say that's 64. And down here, let's say that's minus 64. Okay, so we have minus 264. Let's put that up here, and that's a max, so just draw a little bit of a max there. And then 2 minus 64 is a min, so let's draw a little bit of a min here. All right, so if we just connect everything, we get a rough graph, but we're going to use another piece of information. We discovered here that when we set f prime equal to 0, we discovered that at x equals 0, f prime is equal to 0. So we're going to use that information in a minute. First, let's just connect this up to the max. And here's where we use this information. Instead of just running through 0, we're going to have the curve flatten out when it goes through 0. So it's going to come here, flatten out just because f prime is equal to 0, and then continue down. Okay, and now up again through 2.6. See, when we did these graphs in pre-calculus, we were not able to see that the graph flattened out here, and we were not able to find exactly where the highs and lows were. All right, let me just put this in, minus 264 for the max, and 2 minus 64 for the min. In number 3, again, we're going to do a first derivative test. So let's start by taking the derivative. Okay, bring down the 2/3. And 2/3 minus 1 minus 3/3 is negative 1/3. All right, so here's the first derivative. Now, it's never equal to 0 because the numerator is never 0. The numerator is just 2. But the function that f prime does not exist when x equals 0. And f of x is continuous when x equals 0. All right, so that combination implies that x equals 0, that's a critical value. Okay, a critical value can be either where the derivative does not exist or where the derivative is equal to 0. Okay, derivative does not exist, but f exists. All right, so this one's a critical value. So we're just going to put that one critical value on the number line and do our plus minus analysis looking at this function, f prime. If we substitute in 1, something greater than 0, we get positive. Let's say we substitute in -1. -1 to the 1/3 is -1, so this will be negative. So that means that our function is decreasing here and increasing here. So f is decreasing and f is increasing to the right of 0, decreasing to the left of 0. That means this will be a min. At 0, f of 0. Plugging back into the original function, f of 0 is equal to 0. All right, so that's a min at 0, 0. So we have a min at 0, 0, and we have the decreasing interval from -infinity to 0. That's where the function's decreasing, and the increasing interval from 0 to infinity. And over here we have the min. All right, that's all the information we're asked for in this example. I'll just quickly draw the graph, although we really don't have enough information to draw the graph until we do the next section. But the graph looks like this. It comes down to a point here and goes up again. All right, so that's pretty much y equal x to the 2/3. So this pointy minimum occurred at a place where the derivative does not exist.